All right, today is January 13th. And again, in your notes, you should always put the date and the title. So today we're adding a new thing here, zeros of rational functions. So today we're actually finding some zeros. This turns out to be super easy, okay? So this is what we did on Friday. So pay close attention if you weren't here on Friday. We have this function here, and the difference was that we had a quadratic in the denominator. So anytime we have a quadratic function, the rule is you want to factor it, and that's always going to be super duper useful. So factor first, and then the other thing I wanted to know was, is this already simplified? Is this a simplified fraction? Is it yes or no? Yeah, because there's a number on top. It means it's a reduced fraction. If it's a number like a -1 or a 2 or a 3, if it's just a plain old number, it's been reduced and it is in lowest terms, which means we wouldn't be able to do any sort of division to reduce our fraction into a mixed number. And so because it's simplified, that actually gives us our horizontal asymptote, which really means that horizontal asymptote is y equals 0. And that's because if I were to try to divide, I'd say how many times does like 36 go into -1? It goes in 0 times. It can't do it. It's too big. Okay. And so because we can't divide, it goes in 0 times. That's our asymptote. Vertical asymptotes always come from the denominator. And that denominator, because we can factor it, x times x is x squared. What times what is -3? +3 and -1. There you go. And so we can double bubble. And then if we solve that, x plus 3 equals 0, what does x turn out to be? -3, yeah, and that's one of our vertical asymptotes. And x minus 1 equals 0, then x equals 1. And so those are our 2 vertical asymptotes, which is really handy. They're going to help us graph. And this is really the thing you want to be able to do come test day, which is coming up soon. We have, in fact, I think it might be Friday. So, yeah, so you have one more day tomorrow of lesson, and then we'll probably review, oh, maybe it's Thursday. Better. Yeah, even better. Yeah, there's a test on all these graphing. So get used to those calculators. So we're going to go to -3 on the x-axis and draw our vertical line. I'm going to go to 1 on the x-axis and draw our vertical asymptote. And then I have y equals 0 for my horizontal asymptote, which is just along the x-axis here. So there's our horizontal asymptote. Now, this is where we said, hey, we have a calculator. Let's use it to make our lives a little bit easier. We want to find some ordered pairs. What are some good values for x to use? -2 and -4. Excellent. So to the left and to the right. So -4 is a good choice, and -2. And what are some other good values? 0 and 2. Yeah, to the left and to the right of our vertical asymptote. So 0 and 2. All right, so now in order to get those values, we're going to use the trace feature on our calculators, both types of calculators, but to do that, we have to put the function in. So make sure whenever you're putting in your function into the calculator, you put parentheses around the numerator and parentheses around that whole denominator. So right now, grab your calculator. I go to my graphing menu, delete my function. I'm going to type in -1 divided by x squared. Oh, don't forget your parentheses, ladies and gentlemen. X squared plus 2x minus 3. So I've got that one typed in my Casio, and on my TI, again, parentheses, -1 divided by x squared plus 2x minus 3. And again, make sure that you've got those in parentheses. I'm trying to find the sweet spot. Okay. So for most of these, you can just hit draw or graph. Oh, this is not a super fabulous picture, but it's okay. I'm going to go ahead and show you guys on your Casio. If you get a picture that, I don't know, this is okay. I think it's fine. But viewing window, V window is yellow. And so you would do second viewing window. And you can see how it's kind of got some weird values for your X and Y axis. This middle one here is standard. So I can just do F3, and you'll notice then it goes from -10 to +10. And then I can exit and draw. That's not a better picture, but it's not a whole lot better. So this, you've got to use your imagination. It's not quite as good because the pixels are larger. But it does have that hyperbola shape here. And there's a parabola shape here in the middle. And then this other L shape here. Zoom. Auto. I don't know what that is. Oh, see, that's not better. Zoom back. Huh. Okay. All right. Okay. The point of this exercise is to use trace to figure out our corresponding Y values. So both calculators have a trace button. On the TI, it's right here. It's just you hit trace. And then on the Casio, it's in yellow, so it's a second function. So you do second trace. And then we can just type in -4 and enter or execute. And we get -0.2. Or you can type in -2 and enter, and we get 0.33. 0 and enter, we get 0.33. And 2 and enter, we get -0.2. That's a 2. Okay. Both calculators have that trace. And then we can plot those points for just below the axis. We get that nice little L function hyperbola shape. -2 just above at 0.33 and 0.33. We have a parabola type shape. And then at 2, -0.2, which is just below the axis, again, we have that hyperbola L shape. Okay? All right, ladies and gentlemen, hopefully you will take today to figure out how to work your calculators good. All right, so here we go. Today, building on what we were doing on Friday. Again, in your notes, you should have example 1 and the directions. The directions are very important. Example 1, factor first. Identify the vertical asymptote, horizontal asymptote, and the zeros, and then graph. You'll notice the factor first. Again, we have a quadratic on the denominator. X squared is in the denominator. We also have a quadratic in the numerator. And so anytime we have quadratic functions, that's definitely something that we want to factor. Okay? Always factor. But before I do that, I want to ask you, is this function simplified? No, it's not. How do we know it's not simplified? Yeah, it's not just a number like a 3 or a 2 or 1 on top, okay? It's got x's on top. This is not simplified. So if we wanted to simplify it, we would do long division. but I have a shortcut, so we're not going to do long division because the easy shortcut cheaters method is if the degrees match. So you notice how they're both x squared on top and bottom. If they match, the first step in long division is to ask yourself, how many times does x squared go into 2x squared? What does it simplify to? 2. That is the first step, and that is the horizontal asymptote, which is kind of nice. The x squared on top and the x squared on bottom reduces, and we just get 2. And that comes right from that long division step that we can skip, okay, today. Tomorrow we can't skip it. So when those variables match, they both are x squared or both x cubed, you can just reduce, which is kind of nice, okay? So that those leading terms are always going to give us that horizontal asymptote. But before we do any more, we're going to factor. So let's look at the numerator. What do you notice about the numerator? Two x squared minus 8. What can we do with 2x squared minus 8? Take out a, what can we divide by? 2. Yeah, there is a greatest common factor. So we're going to take out the 2. I'm sorry, I took out a negative. We're going to take out the 2. What's left behind if we take a 2 out? X squared minus 4. Good. And then that x squared minus 4, we can double bubble again. Diego, how does this double bubble? X times x is x squared and minus 2 and plus 2. Good, thank you. Now, the denominator, we can also factor the denominator. I'm just going to leave it right now. X squared plus 2x minus 3. I'm going to go ahead and double bubble it here. Jordan.
X.
All right, x times x is x squared, and then what times what is negative 3?
Plus 2 plus 3.
Positive 3, negative 1. There we go. All right. Now, it turns out that you can see this right here, the 2 is that horizontal asymptote. That's kind of nice. Right there, that horizontal asymptote. What does the denominator tell us? What information do we get from the denominator? The vertical asymptotes always come from the denominator. So that's really easy. We're just solving for those. If x plus 3 equals 0, what's x? Negative 3. X equals negative 3. Good. If x minus 1 equals 0, what's x? 1. Mm-hmm. All right. So the vertical asymptotes always come from denominator. Guess what comes from the numerator? The zeros come from the bubbles in the numerator. So again, solving zeros is just a fancy word for x-intercepts. And so again, we can solve if x minus 2 equals 0, what's x? Positive 2. And if x plus 2 equals 0, what's x? Negative 2. So these happen to be the x-intercepts or zeros, which are ordered pairs. 2 for the x, 0 for the y. And negative 2 for the x, 0 for the y. So that numerator is really kind of nice. Now we can use all of this information to help us graph, and then we'll use our calculator. The nice thing is when we have zeros there, they're ordered pairs. So there are already some x and y values that we can plot right off the bat. So we're going to go to -3 on the x-axis and draw in our vertical asymptote. Going to go to 1 on the x-axis and have another vertical asymptote. We're going to go to 2 on the y-axis and have a horizontal asymptote. And I have a couple ordered pairs, +2, 0 and -2, 0. I have no idea what this looks like though. And so despite the fact that that's helpful information, I'm still going to use my calculator to help me get a picture and help me find some values. All right, so for all of my Casios, I'm going to exit, and it's going to take me back to y equals. So push exit, and then delete the equation. And TIs, you can just go back to y equals and press clear. All right, remember when you're plugging this into your calculator, you need to use parentheses around the numerator and parentheses around the denominator. Be very careful. So I'm going to do 2x² - 8 divided by x² plus 2x minus 3. And once you get that in there, you can go ahead and draw or graph. Draw or graph. Interesting, yeah? It's a little different. Okay, so again, we have a basic idea of what this should look like. So what's happening at 2? The little L shape right there at 2. So we have our little L-shaped hyperbola in the corner, just like before. We have an interesting S shape in the center this time. It's going to be different every time, so having a calculator is going to be super helpful. We can pick a number. Here we are at 1 on the x-axis. What's another value for x we could plug in? What's to the left? 0. Yeah, so 0. I'm going to go ahead and do trace 0, and I get 2.66. So 0, 2.66 is about right there, and it's this sort of S shape through there, stretchy S. And what do I need to the left of -3? We're going to choose another x value, so I'm going to choose -4 because I need another point to the left of my asymptote. So I'm typing -4, and I get 4.8. -4, 4.8. 1, 2, 3, 4.8. Not quite 5 right there. And again, that's going to be our little L shape nestled in the corner. So just like before, we want points to the left and the right of each asymptote. And you can use your calculator to help you out. 2, 0, and -2, 0 come from our zeros, which is kind of nice. All right, questions on that one? All right, I have one more for you to get more practice on. Okay, here we go. All right, we have y equals x² - x - 6 over x² - 1. What's the horizontal asymptote? 1 is correct. Very good. Right here. We can divide our leading ladies. What is x squared divided by x squared? 1. So that's our horizontal asymptote, just looking at those leading terms. Really easy. Then we're going to go ahead and factor. How does x squared minus x minus 6 factor? X times x is x squared. What times what is negative 6? Negative 3 and positive 2. Very good. So what do these bubbles in the numerator tell us? What information does the numerator give us? The zeros. Very good. Write that down. Those are the zeros, which means if x minus 3 equals 0, what's x? X is 3. Here we have x plus 2 equals 0, so that means x equals negative 2. Yeah, so our zeros are 3 for the x, 0 for y, negative 2 for x, 0 for y. That's why they're called zeros, the 0 for y part. All right, we can go ahead and factor the denominator. How does x squared minus 1 factor? X times x is x squared. What times what is negative 1? Positive 1 and negative 1. What do we get from the denominator? BA, vertical asymptotes, which means if x plus 1 equals 0, what does x equal? Negative 1. If x minus 1 equals 0, then x equals 1. Okay. So x equals negative 1 and x equals positive 1 for our asymptotes. Most of this stuff is super fast to find. The hardest part is literally typing it into your calculator correctly. All right, I'm going to go to negative 1 on the x-axis and draw my vertical line. Positive 1 on the x-axis and draw my vertical line. I'm going to go to 1 on the y-axis and make a horizontal asymptote. And for the zeros, it's an ordered pair, so it really is like the ordered pair 3. If we plug in a 3, we'd spit out a 0. So 1, 2, 3, 0. Negative 2. If we plug in a negative 2, it would spit out a 0. What do you suppose goes in these little corners here? The little L shape, yeah. So we got the hyperbola and the extremities here, that little L shape. What do we need in between these asymptotes? I'm missing stuff in between. What's another x value I should plug in? 0. Yeah, so 0 is right in between. What is 0 squared minus 0 minus 6? Negative 6. And 0 minus 1? Negative 1, right? All right, we're going to go ahead and plug this into your calculator. Remember, you have parentheses around the numerator and parentheses around the denominator. So on the Casio, I'm going to go ahead and hit exit the graphing, and then delete F1. Exit and delete. All right, and then I'm going to do parentheses, x squared minus x minus 6 divided by parentheses, x squared minus 1. And I'm going to graph it. Oh, this one's interesting. We've got our little L shapes, and what do you see in the middle? A little parabola shape there. So again, I want to figure out the y value. So I'm going to do trace shift trace, and 0 we get 0, 6, which we could also get negative 6 divided by negative 1 is positive 6. So right there at 6, we have this little parabola shape in the middle. Okay? So your calculators are really, really helpful. All these graphs are just slightly different. Use your calculators. Do you have any questions for me? All right.
Yeah, I finished.
This is piece 6. Ladies and gentlemen, this is class practice 6. Please put your seat number on your paper. Please, please, please. CP6. CP6. Don't forget your seat number. You should have no problem turning this in before you leave. You're factoring all 3 terms. 1 times what? The x squared. First times first has to be first times first has to be the first thing, and then what times what is the last thing? The last thing. So negative 6 times 1 is negative 6. Negative 3 times. How do you know if you did it right? That's where it's left, right, same thing.
Yeah, because you're good, Isaiah.
Yeah.